You walk into a modern conference room or, a classroom, you look up and see this discrete white disc on the ceiling.
Right, usually just blending in with the tiles.
Exactly. And you probably just assume it's there to, well, make sure the remote team can hear you breathe during a meeting. But today, our mission for this deep dive is to look at the Gain Audio HT Satellite CM ceiling microphone.
Which on paper is just a $280 piece of standard AV hardware.
Right, but we are digging into the source material to discover how this seemingly ordinary, everyday tech is quietly transforming public safety.
Yeah, it completely redefines what we expect from like hidden architecture. I mean, what looks like purely utilitarian audio equipment is actually operating on a totally different level underneath.
Okay, so let's unpack this. We are not going to bore you with the exact millimeter dimensions or the plastic housing specs.
No, nobody needs that.
Right. What really matters is what is inside. This unit packs a 4-part MEMS microarray,
And for those wondering, MEMS stands for microelectromechanical systems.
which sounds incredibly sci-fi.
It kind of is. Instead of traditional bulky microphone diaphragms, these are microscopic mechanical structures that are etched right onto silicon chips.
Oh, wow. So right onto the silicon itself.
Exactly. They measure changes in air pressure on a microscopic scale.
Hmm.
That is how this array gets a highly sensitive, omnidirectional range of about 3 to 5 meters.
So it is essentially carving out this massive acoustic bubble in the room. And the thing is, you don't just hang one of these.
No, you can daisy chain up to 4 of them together.
Right, using just standard category cables. So my mental image here is like less like a standard microphone and more like weaving an invisible audio safety net over the room.
I like that, yeah. Because they are not just passing raw audio down the wire.
They are doing a lot of active processing, right?
Oh, definitely. What is fascinating here is the onboard tech. These mics automatically share background noise reduction and smart acoustic echo cancellation, or AEC.
And AEC is what keeps the audio from sounding like a cavern.
Yeah, the way AEC actually works is just fascinating engineering. The system basically listens to the audio coming into the room from a remote speaker, and then mathematically predicts how that sound will bounce off the walls and tables.
Wait, it predicts the bounce?
Yes, and then it generates an inverse sound wave to cancel out that specific echo before it ever reaches the mic.
That is wild. It is running complex phase inversion algorithms in real time, so someone dropping a pen or a loud AC unit turning on doesn't totally derail the feed.
Exactly. Plus, there is automatic gain control that dynamically boosts quiet voices in the back corner.
But here's the thing that really trips me up. If you are just trying to get clean audio for, say, a quarterly earnings call, all of this synchronized mapping and onboard computing seems like massive overkill.
It does seem like a lot for just a meeting.
Right. It feels less like an AV setup and more like a high-speed data network. So why does an audio network need all this power?
Well, that realization is exactly what shifts the paradigm of this hardware. These ceiling mics don't just operate in a vacuum.
Okay, what do they connect to?
They plug into a much broader network called the HT CommAlert Audio Reinforcement and Digital Safety System.
Got it.
And the brain coordinating that whole system is a DSP automated controller.
A DSP, meaning a digital signal processor. So that's a dedicated microprocessor designed to crunch continuous real-world signals, like audio, instantly.
Yes, exactly. It is managing that complex audio traffic, but it is also monitoring the network for specific non-audio digital triggers.
Non-audio triggers? Like what?
Well, the HT CommAlert system pairs that overhead mic grid with a wearable wireless microphone for the presenter or the teacher.
Which makes sense, so they can walk around freely while the ceiling grid handles the audience.
Right, but built right into that wearable mic is a discrete panic button.
Wait, really? A panic button. So if a teacher presses that button, how does the system know the difference between just another audio signal and an actual emergency trigger across the exact same network?
That is where the DSP comes in. When that button is pressed, it bypasses the audio stream entirely.
Oh, so it doesn't even register as sound.
Right. The DSP recognizes the encoded digital trigger and immediately routes a silent alarm through the building's network infrastructure directly to law enforcement.
That is incredible.
It is. It is engineered to be fully compliant with Alyssa's law, which mandates that public schools have silent panic alarms directly linked to first responders.
So that ultra-clear, echo-canceling audio grid we were talking about earlier, it is really kind of a Trojan horse.
It really is, yeah.
I mean, the facility buys an audio upgrade to ensure the people in the back row can hear clearly. But the category cables daisy chaining those mics are secretly laying the physical track for an instant emergency response system.
Exactly. The audio reinforcement is almost a secondary benefit to the physical security infrastructure it actually provides.
We started this deep dive looking at a little white disc that uses microscopic silicon to cancel out room echo.
Just a standard piece of hardware on the surface.
Right, sharing noise reduction across simple category cables. But when you zoom out and look at the DSP controller routing silent alarms through the network, you realize this hardware is actually the backbone of a sophisticated digital safety net.
It is a complete shift in how we look at infrastructure.
It really is. And it leaves you with something pretty profound to mull over. If classroom and boardroom audio equipment is now quietly doubling as emergency infrastructure compliant with Alyssa's law, what other invisible everyday technologies around you might be secretly operating as emergency security networks? Next time you look up at a boring ceiling tile, you might just be looking at a lifeline.